Today, let's talk about the process of finding the base of an exponential function even when you don't have a complete table of values for the exponential function. Maybe, as in this problem, you are only given 2 points that this function passes through. You are only given information that when the x is 1, y is equal to 2, and when the x is 4, y is equal to 16. So let's sketch a little table. We're told that when x is 1, y is 2. And we're told that when x is 4, y is 16. Now the problem is that just from these 2 points, we can't identify the base on sight because we're not increasing x by 1 to get from 1 to 4. We are increasing x by 3, increasing by x 3 times. Now, we increased x in total 3 times, which means that we must have multiplied by the base 3 times. In total, 3 times we multiplied by the base, moving from 2 up to 16. So, let's make some notes. X increased by 3, so 2 was multiplied by b 3 times in total. To get 16. So let's parse that into an equation. And let's translate this statement, 2 was multiplied by b 3 times to get 16. And here's what I'll write. I'll write 2 multiplied by b 3 times was how to get 16. Now, we can use exponents to rewrite b times b times b in a more compact and familiar form. So instead of 2 times b times b times b, I'm going to rewrite this as 2 times b to the power 3. Now, do you recognize this variety of equation from yesterday? Here we have number times b to a power equals 16. And our job is to find that number b, is to solve for b, to solve for the base. So let's use the process that we learned yesterday. Let's start by dividing both sides of the equation by 2. And that gives us b to the power 3 equals 8. And then let's use the nth root where n is 3. And we get b is equal to the third root of 8, which we found yesterday, means that b is equal to 2. And this b equals 2 would be our final answer. What is the base of the exponential function that goes through the 2 points 1, 2, and 4, 16? The base would be 2. Okay. Let's try it again. Find the base of the exponential function that goes through the 2 points 1, 18 and 3, 2. So let's set up a quick table. When x is 1, y is 18. And when x is 3, y is equal to 2. So in total, x is increased 2 times, plus 1 again, to go from 1 to 3. Which means that the y value must have been multiplied by b 2 times. So x increased by 3 minus 1 equals 2. 18 multiplied by b, a total of 2 times then, gives you 2, the final y value. So let's set up this equation in an exponential form. 18 multiplied by 2 copies of b results in 2. So, just like before, let's go ahead and solve this for b, starting by dividing both sides by 18. b squared is equal to 1 over 9. Now, in yesterday's material, we got to assume that b was a positive number. And when we are doing these calculations, we get to assume the same thing. Bases of exponential functions are always assumed to be positive. Always, always. Unless you were told something really strange, if it's not otherwise said, bases are always assumed to be positive. Which means that when we get rid of this square, by using the square root, we don't have to worry about plus minus. We can take b equals the square root of 1 over 9, no plus minus, because b is positive, and that can be simplified to 1/3. b equals 1/3 would be the base of the exponential function that goes through these 2 points. X increased by 2, moving from 1 to 3. So the y value must have been multiplied by b 2 times in total. So we translated this statement into an equation and used that equation to solve for b. So let's summarize the general process that we've used in the previous 2 problems. We have 2 points, x1, y1, and x2, y2. And we're asked to find the base of the exponential function through these 2 points. So the first thing that you need to do is you need to figure out how much x has increased. Calculate the last x minus the first x to figure out how much x has increased. Let's compare this with the following example. In the directly previous example, moving from 1 to 3, x increased by 2, which could be found by taking the final x, 3, and subtracting the initial x, 1. 3 minus 1, 2. And in our very first example, we found that x had increased by 3, 3 being the difference, final x 4, minus initial x 1, 4 minus 1. So the first thing that you want to do is you want to do last x minus first x, take that difference to figure out how much x has increased. So let's call this number n. Okay, then the next thing that you need to do is you need to set up the equation take the first y, multiply it by b n times, and that should give you the second y. Let's compare this with what we did in the previous examples. In the previous example, we said, okay, the first y, 18, multiplied by b 2 times, resulted in the final y value of 2. First y times b 2 times equals 2. Likewise, in the first example, we said first y, 2, multiplied by b 3 times, resulted in the final y, 16. The last thing that you need to do to find the base is to just solve this equation that you have set up. Solve this equation for b. And you get to assume that b is a positive number. B is positive. All right, so that's the general process. If you're given 2 points, and you know that there is an exponential function going between those points, and you're asked to find the base, figure out how much x has increased, multiply the first x by b that many times, set it equal to the last y, and solve that equation for b. Now let's close with one final example. Here we're not asked to find the base of the exponential function, we are asked to find the formula for the exponential function, which goes to the 2 points 0, 7, and 3, 448. So let's consider the general form of an exponential. The general form was f of x equals a b to the x. And let's remind ourselves that b was the base and a was the y-intercept. So all that we need to do is figure out the base and figure out the y-intercept, and then we can put those numbers into the general form and the problem will be done. Now look at the points that were given. Has any information been given to us about the y-intercept? Well, the first point that we're given is fantastic, because in the first point we have x equals 0, and therefore the y value of 7 is the y-intercept in this problem from the point 0, 7. We know that the y-intercept is equal to 7, the y value that goes with x equals 0. So all that's left for us to do is to find the base. So let's use the process that we described and used in the previous examples. The first thing that I'm going to do is I'm going to figure out how much x has increased. And so I'm going to say, moving from x equals 0 to x equals 3, how much did x have to go up to go from 0 to 3? Well, x had to increase 3 units to go from 0 to 3. So 3 is the exponent n. Next, I'm going to use 3 and set up the equation where I take the first y, multiply it by b to the power 3, and set it equal to the final y. So our first y value is 7. 7 multiplied by b 3 times in total results in the final value of y equals 448. All right, so let's clean this up. Let's get rid of that multiplied 7 by dividing by 7. Let's go to the calculator. And so we have 448 divided by 7 equals 64. B to the third power equals 64. And let's get rid of that third power using a third root. B is equal to the third root of 64. Now let's see if that number cleans up nicely. I'm going to go ahead and take 64, and I'm going to raise it to the power 1 divided by 3, corresponding to the third root. Close parenthesis, enter, and it says to me that the base is 4. Alright, so now we have done the work to find the base. We have identified the y-intercept. So we now know that a is 7 and b is 4. So let's finish the problem, and we have the formula. F of x is equal to a being 7, b being 4, raised to the power x. And this would be the final answer to the question, what is the formula?